Alright, so here we have an acid-base type problem, and you can tell the base, that's the one with the OH in it next to the metals, and the acid will have the H in it. The H here happens to be in the middle. Alright, so starting out with this one, we'll have BaHSO4 2 plus BaOH2. As I said, the OH and the H will join together, and that will form water. And then we'll have the Ba joining with the SO4. Now, I don't know what compound that's going to form yet, but I will find out in a second. First thing I want to do is try and figure out what the charges on these are so that I can answer these particular questions here. And you can see if you've got BaOH2, if we know that OH has a -1 charge, you can see that that's going to total out to -2, which means that the total positive charge over here must be +2, which means that the charge on Ba must be +2. So that'll be the answer to this one, Ba2+. And the other one over here, we've got BaHSO4 and it's leading to BaSO4. And what we know is that we've got SO4, and that's a polyatomic ion, which is going to have a charge of -2. Alright, so we can get that off the polyatomic ion sheet, the SO4. So we've got Ba2+ and SO4 -2. We've already answered those, but let me continue on and just show you how to complete the problem. So just writing this out again. And the question I'm asking myself is how these two are going to join together. Well, you've got one Ba2+ and one SO4 2-, that will balance out. So it's just BaSO4. So that effectively becomes compound A for that one. The next thing we want to do is balance the reaction. We've got Ba here and a Ba here, that's two Ba's. So I'm going to put a 2 in front of here. And you'll notice that also would lead to two SO4s. And you can see we've got two SO4s here and two SO4s here. So that's balanced as well. Now for the water, we've got to look at that. And you can see we've got two oxygens here. So I'll need to put a 2 in front of that one. Let me make that a little bit clearer. Move that over a little bit. Alright, so that'll be a 2 in front of the water to fix up the oxygens. Now for the hydrogens, we've got two hydrogens here and two hydrogens here. That's a total of 4, so that balances out as well. Just remember that if we've already figured up the SO4s, we don't have to worry about the oxygens in those because we already took account of those when we took account of the SO4 groups. Alright, so that's for numbers 20 and 21. Let's take a look now at the other ones. Okay, so we've got CaHCO3 2 plus CaOH2. This is another acid-base problem. And again, you've got the OH here and we've got the H in the middle of the compound. We know those two are going to join together. That's going to give us our water. And then what's left will be the Ca joining with the CO3 part over here. And that'll be Ca and CO3. Now we have to figure out the charges on these here, and again we can use the same process as we used before, and we can say, well, if we've got OH here and there's two of those and we know that each of those is -1, then that's going to be -2 total over there, which makes that +2 to match it up, and that's going to be a +2 charge here as well. So the charge on the calcium is going to be 2+. And if we look on the polyatomic ion sheet, we can find a charge of CO3, and it's going to be -2. Alright, so that's going to be our answers here. We'll have Ca2+, and we'll have a CO3 2-. So those will be the ions involved in compound A. But just finishing up the problem, what we'll do is just write this out again. I always recommend writing these out the second time after you've got the charges. Makes things much easier. And we've got the H2O, and you've got Ca2+ and CO3 2-. That'll just join together to form CaCO3. 2 plus 2 minus, that'll cancel, we just need one of each. Alright, so that's compound A right there. Now I can balance this up. I see I've got 2 calciums here, so I'll put a 2 in front of this one. And now my CO3s are balanced as well. I'll have 2 CO3s here and 2 CO3s here, so that's okay. Now I look over here at the oxygens, and I see I've got 2 oxygens here, so I'll need to put a 2 in front of the water. And you can see that that's 2 hydrogens and 2 hydrogens, that's 4, so that's balanced as well. Alright, so now that one is completed too.